suppose that we're playing a game in which 2 tails wins the game. Then what's the probability that you get 1 tails, or that you got 1 tails, given that you lost? Okay, again, we assume that you lost. What's the probability that you had exactly 1 tails? Now, if you lost, that means you didn't get 2 tails, which means that you either got 1 tails or no tails. Now, how many ways are there for that to happen? We can look at it this way. We have the tree diagram indicating all the possible outcomes: heads, 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 tails, tails, heads, tails, tails, as indicated. Now, we're looking for the probability of 1 tails given that you lost. Okay, if you lost, that means you had one of these 4 or one of these 3 outcomes. The 4th outcome, tails, tails, didn't happen because we know that you lost. So this is your reduced sample space, and we can analyze the problem within this sample space. The reduced sample space has a probability of 3/4. That is, there's a probability of 3/4 that on 2 flips of a coin we're going to land in this reduced sample space. Now, within this space, the probability of 1 tails is 2 out of 3. Okay, we can look up at the reduced space. We have 1, 2, 3 outcomes, and in 2 of them you have exactly 1 tails. So that the probability of 1 tails given the loss is 2 out of the 3. If we look at this, okay, there are 2 ways to look at it. One is to look at just the reduced space. We see the 2 out of 3. If we look at the original space, then the probability of 1 tails given a loss is, well, it's the probability of 1 tails and a loss over the probability of a loss. Okay, because remember, the probability of A given B is the probability of A intersection B or over the probability of B, right? So there's A, 1 tails, and B, loss, over probability of a loss. Now, what's the probability of 1 tails and a loss? Well, how many ways can you lose getting 1 tails? Any way you get 1 tails, you're going to lose. So the probability is 2 out of 4. There are 2 ways to get 1 tails out of the 4 outcomes in the sample space. Now, again, we're looking at the original space, the whole sample space. So the probability of 1 tails and a loss is 2 out of 4. If we look up at the sample space, we see that we're going to look at the whole sample space, and there's a tails and a loss, there's a tails and a loss. That's 2 out of the 4. Now we divide that by the probability of a loss, which, as we said, is 3 out of 4, and we see that the probability of 1 tails and a loss over the probability of a loss is 2/4 over 3/4. We invert the denominator and multiply, and we end up with 2/3. So the probability of 1 tails given a loss is 2/3. So we found that by looking at the reduced space, and we found that by looking at the probabilities in the original space. Now let's look at another situation here. Okay, this table represents, in this direction, the number of hours per week students put into a certain course. And this is the score range. Okay, so for example, score range, let's say, on a test. For example, if people had spent 0 to 2 hours per week on the course, 10 of them made 0 to 25 on the test. 8 made 25 to 50, and 2 made 50 to 75. Nobody made 75 to 100. Now, the people who spent the most hours per week, 4 to 6 hours per week, nobody made between 0 and 25. Nobody made 25 to 50. Everybody made over 50. Now, there were 6 who made between 50 and 75, and 12 who made between 75 and 100. So we understand this table. Now let's look at various probabilities in terms of this table. Okay, what's the probability, for example, of getting 50 to 75 given 0 to 2 hours per week? That should be obvious which range the numbers fall in, whether this represents a score and this represents hours per week, because 50 to 75 is one of the score ranges, 0 to 2 is one of the hours per week ranges. We can immediately tell by looking which is which, so we don't really have to put a whole lot more detail in our description. Okay, probability 50 to 75 given 0 to 2. What's that mean? That means we're going to look at the 0 to 2 column, just at the 0 to 2 column. And the probability of a 50 to 75, well, 50 to 75, there are two of them in the whole column. In the column there are 20 outcomes, or 20 individuals. So we see that 2 out of 20 individuals who made 0 to 2, who studied 0 to 2 hours per week, made 50 to 75. And there's the probability. Okay, the probability of 75 to 100 given 2 to 4 hours per week. Well, now we're in the 2 to 4 hours per week column. We know that there are 2, 12, 18 people in that column. Out of those, the 75 to 100 range, there were 6. So that's 6 out of 18, 1/3, 0.33, repeating. Okay, what's the probability that somebody made more than 50 given that they studied more than 2 hours per week? Well, more than 2 hours per week is the 2 to 4 and 4 to 6 columns, so we're going to include both columns with a total of 34 people if we add up these numbers. 36 people, I'm sorry. Now, how many of those made greater than 50? Well, all of them except these two, right? So that leaves 34. So it's 34 out of 36, which of course reduces to 17 out of 18. And we can put that in decimal equivalent if we wish. What's the probability of making greater than 50? Well, sorry, I'm asking as if it's a new question. Another way of looking at that probability is it's the probability of making more than 50 and making more than 2 divided by the probability of studying more than 2. Okay? So the probability of making more than a score of 50 and studying more than 2 hours divided by the probability of studying more than 2 hours. Now, what's the probability of making greater than 50 and studying more than 2 hours? Well, if we look at the table, the greater than 50s are in these two rows. The greater than 2 hours are in these two rows, and there are 10, 16, 22, 34 people who made greater than 50 and studied more than 2 hours. Divide that by the probability of studying more than 2 hours. Well, we saw that there are 36 people who studied more than 2 hours. Now, what are the probabilities? Okay, the probability of greater than 50 and more than 2 hours is 34 out of 56. We add up all the people in the whole sample space, and that's our probability. So the probability of more than 50 and greater than 2, 34 out of your 56 people did that. The probability of greater than 2 is 36 out of 56. When we divide these, we get 34 out of 36, the same thing we got earlier.